Hello, this is Mrs. Huntley. This is Module 1, Lesson 4B. You should have your supplemental packet that looks like this on the front, and if you remember when you listened to Lesson 4, you filled out this page. Your essential question, how do I write equivalent expressions for exponential expressions that are raised to the 0 power or a negative power? And this entire first page should be filled out. This is in Lesson 4. So if you haven't watched Lesson 4 yet, you're going to want to stop the video right now and go back and pick up Lesson 4. This page we went through and we talked about it together, and then we got to this page, the negative exponent rule, and we didn't have time for it. So today we're going to pick up, or this lesson, we're going to pick up with the negative exponent rule. And we're going to look at the first example here, which they've done for us as a way of modeling how to do the rest of it. So I've got 3 to the 3rd power divided by 3 to the 5th power. And if you remember when you did Lesson 2B, dividing exponential terms, we learned that it's a division problem. So when you have the same base in the numerator and the denominator, they end up canceling themselves out. So in column 1, we rewrote it in an expanded form. So that's in the numerator, I've got 3 multiplied by itself 3 times. In the denominator, I've got 3 multiplied by itself 5 times. Now, I'm not really crazy with how they line this up. I probably would have taken these 3's over here to have them lined up and just in order, but that just is the way that I organize things. If you remember, when you have the same numerator and the same denominator, a lot of people say they cancel each other out. It's not that they're canceling each other out, but 3 divided by 3 is 1. So 3 divided by 3, these are all going to become 1. So what's left in my numerator is 1 times 1 times 1, or just the 1 up here. And then in my denominator, I've got 3 times 3, 3 to the 2nd power, or if I multiply that out, that would be 9. So I've got 1 over 9. I'm going to leave it right here. Let's talk about that one right there. If we use our quotient rule, which we also learned in Lesson 2B, we take our exponent from the numerator and we subtract the exponent in the denominator. So my numerator exponent is 3, my denominator exponent is 5, so I'm going to take 3 to the 3rd minus 5, which is going to be 3 to the negative 2. So now we're going to compare our answers, the one written as a fraction and the other one written in exponent form. So first, in the first column, we got 1 over 3 to the 2nd power, right here, 1 over 3 to the 2nd power. And in the 3rd column, we got 3 to the negative 2 power. So we're going to say that these are equal. So if I am asked to solve this equation, really either answer is correct. However, usually you're going to be asked to give your answer without a negative exponent. So if you're asked to give, if you get this for an answer, but the directions say, or you're being directed to write your answer without a negative exponent, the way you would change this negative exponent into a positive exponent is by taking the reciprocal. You just put it 1 over 3 to the 2nd power. Let's take a look at a couple of these and see if it becomes more clear as we actually work some out together. So column 1 says write it in an expanded form. So I've got a to the 4th power. So it's going to be a times a times a times a divided by a to the 7th power. A times a times a times a times a times a times a. 1, 2, 3, 4, 5, 6, 7. Okay. A divided by a is 1. A divided by a is 1. Those all become 1. So in my numerator, I've got 1 times 1 times 1 times 1, which is 1. In my denominator, I've got a times a times a, which is a to the 3rd power. If I use my exponent rule, I'm going to have a to the 4 minus 7 power, which is going to be a to the negative 3rd power. So what I'm saying is 1 over a to the 3rd power is equal to a to the negative 3rd power. I hope that this is making sense to you. Again, if you're, say we're looking at an assessment and you have a problem like this, a to the 4th power divided by a to the 7th power, I would not expect you to expand it out and to give me this answer here. However, if that is making sense for you, if you're like, I don't get what you're doing with the subtraction thing, that subtraction shortcut is just kind of messing with my head, Mrs. Huntley, fine. Go ahead and expand them out. You'll prove it to yourself. The only time that becomes a problem is like when they start getting super long like this and it becomes kind of tedious to expand them out. Now this next one, we can still expand out, but the last one we're going to have to use the shortcut and be comfortable with it. Okay, so if you are comfortable with this, you can go ahead and pause the video at this point, see if you can expand out this next problem and figure it out, and then come back and check your rule, or check your answer. Oh my goodness, I gotta get my coffee in me. Okay, so I'm going to continue with the recording because I'm not telling you that you have to pause it here, but if you're comfortable, you can go ahead and do that and then skip to the answer. So my numerator, a to the third power, b to the sixth power. So that's going to be a times a times a. Now I'm going to skip some space here because I've got a to the sixth power in the denominator, and I just want to make sure that I don't get too messy. I want to stay organized. And now I've got b to the sixth power, so it's going to be b times b times b times b. 3, 4, 5, 6. Okay, so there should be a times there. Okay, there's my numerator. My denominator, a to the sixth power, a times a times a times a times a times a. B to the 10th power, oh boy. 4, 5, 6, 7, 8, 9, 10. Okay, so this becomes a 1. These are all 1s. These are 1s. So my numerator is going to be a 1. My denominator is going to be a. I've got 3 of them there, so a to the third, b to the fourth. See, when I use my shortcut, I've got to keep my like term or my bases together. So I've got a to the 3 minus 6, and then I've got b to the 6 minus 10, which is going to give me a to the negative third, b to the negative fourth. I went ahead and color-coded that so that you saw I was taking the a terms first and then the b terms. So again, what is this showing us? It's showing us that 1 over, oh, I meant to switch to blue here, 1 over a to the third, b to the fourth is the same thing as a to the negative third, b to the negative fourth. They equal each other. 2 different ways of writing the same expression. So this last one, they're telling us flat out, it's too long. Don't try to do it expanding it out because you're just going to make yourself crazy. So let's keep our bases that are the same together. So I've got 4, 15 minus 20 power, and then I've got a to the 30 minus 50 power. So my answer is going to be 4 to the negative 5, a to the negative 20. So if I'm asked to rewrite that using only positive exponents, it's going to be 1 over 4 to the 5th power, a to the 20th power. Now, I'm going to share a little trick with you that I used when I was in middle school because I don't know if I've shared my math story with you, but I had to come up with tricks to figure things out because I was not a super strong math person when I was in middle school. I used to personify things, which means I used to pretend that they were like human beings or not so much human beings, but living objects. So I always kind of envisioned a negative exponent to be a person with their finger sticking out to hit a button on an elevator. And the elevator is your fraction bar. So if I've got, say I've got 4 to the negative third power, and it's in my numerator, why won't my thing write again? Let's see. I've got 4 to the negative third power over 1. And that negative 3 is my person that's pressing the elevator button. That negative means it's going to travel down, and my 1 is going to end up on top because nothing is going to be left there. It's going to take its base with it. And when it travels down, as it passes that fraction bar, the negative sign falls off. So 1 over 4 to the third or 4 to the negative third is the same. Now, you might be asking, why did I put it over 1 here? Because any whole number over 1 is just itself. All right, let's start answering the rest of the questions. Explain what a negative exponent means. A negative exponent means I need to take the reciprocal or flip the fraction. Again, need my coffee. That's basically what we're doing here. When we have a negative exponent, it's going down into the denominator. I'm flipping that fraction around. Similarly, if my negative were already in the denominator, I'd be flipping it up to the numerator. It just means that negative means the exponent wants to take whatever base it has to the other floor. If it's in the basement, it wants to move up to the first floor. If it's on the first floor, it wants to move down to the basement. So let's take a look at some examples. A, 4 to the negative first power. Again, remember, any whole number you can say is over 1. So if I'm flipping that fraction around, that's going to be equal to 1 over 4 to the first power, or just 1 over 4, because we generally don't write it when it's over the first power. Why don't you pause the video and see if you can get B done by yourself? Okay, B. Again, I put it over 1 to start just so I could visually see that I'm actually flipping that flat fraction over. C is not more complicated. The whole thing is going to be moving. When it moves, the exponents are no longer negative. Now D might look a little bit more complicated. Remember, the only thing that's moving is the thing that has the negative exponent. So if I put it all over 1 right now, let's see, does A have a negative exponent? Yes, it does. So that's going to move down into the denominator. So A is going to be to the third power. B is going to stay exactly where it's at, up in the numerator. It does not move. Okay, E is one of those that I was talking about earlier. It's already in the denominator. So if my negative is in the denominator here, it's going to move up to the numerator. So I'll have A to the positive fifth. I could say over 1, but everything is over 1. So I would actually just write this as A to the positive fifth power. Okay, the next one here, we've got a division, and this is a little bit complicated. So I'm going to go ahead and color code here so you can see that I'm keeping my A's together, and I'm going to use my division rule. So A to the 2 minus 3 power. I've got B to the first power on top and B to the negative 4 on bottom, so B to the 1 minus 4 power. And then there's just a C in the numerator to the negative third power. So let's go ahead and do these subtractions. A, 2 minus 3 is going to be negative 1. B, 1 minus 4 is going to be negative 3. And C is to the negative third. So all 3 of these terms are going to be moving to the denominator. So when I write this answer, it's going to be 1 over A, B to the third, C to the third. Oh, those 3's don't look like 3's, do they? I'll try to fix it. There we go. Okay, now we're multiplying, and remember when this is from lesson 2A, we need to, we could regroup our terms so that we have our like terms together. So we could say 4 times 3 times n to the second power times n to the third power. And then our 4 and our 3 can just be multiplied together. That's going to be 12. And then I have n to the negative 2 plus 3 power. Remember, when we're multiplying exponents, we keep our base and we add our exponents. So when I simplify this further, I'm going to have 12n. Negative 2 plus 3 is 1. So it's going to be 12n to the first power, or just 12n. I hope that makes sense to you. These are a little bit more complicated, I get that, and now we're bringing back in some of the older properties that we were looking at in previous lessons. So the next one, h, m to the fifth times n divided by m to the second times n to the third. So again, this is a division, so I'm going to group my m's, and I'm going to group my n's, but I just wrote a line through them, so they're hard to see now. So let's group m's with that. And I know I just changed colors on you, but I couldn't see it good. Okay, so m to the 5 minus 2 times n to the 1 minus 3. Remember, when there's nothing there, there's a 1 there. So m, 5 minus 2, is going to be m to the third power. 1 minus 3 is negative 2. Now if I'm asked to rewrite that with no negatives, my m is going to stay in my numerator, my n is going to go down to my denominator, and my exponent would become positive. Okay, the next one, we've got a power to power. When we have power to power, we multiply. So this is going to be m to the negative 3 times 2 power, or m, negative times a positive is going to stay negative, so that's going to be m to the negative 6 power. If I'm asked to rewrite that using only positives, it's going to be 1 over m to the positive 6 power. I hope it's starting to get a little bit more manageable and easier for you. Okay, number 1 says simplify each of the following and order them from least to greatest. Least is your smallest amount, greatest is your largest amount. So the thing that I'd like to do, right now, I'm looking at this. Okay, we have to remember back to an earlier lesson when we have to remember what the parentheses do. So if the parentheses are there, it means the exponent is taking the negative 6 times negative 6 times negative 6 times negative 6. So that's going to be a positive number, because a negative times a negative is a positive. A positive times a negative is a negative, negative times a positive. So if it's an even number up here, you're going to end up with a positive answer. So this is going to be a positive answer, and it's going to be quite large. Now this next one, negative 6 to the 0 power, remember, last lesson, anything raised to the 0 power is 1. This next one here, the 4 is only attaching to the 6, not the negative sign. So however large this number is going to be the same number, but it's going to be negative, because your 6 is the only thing being raised to the 4th power. So it's going to be a very small number. It's going to be a negative number. So we're going to figure this out without even using a calculator. Here we have a negative exponent. So we know when we have a negative exponent, it's going to be a fractional number. It's going to have a couple of zeros in front of it. So this is going to be a super small number. Okay? But it's not going to be negative, because this is even here. So I know it's going to be positive, but it's going to be super small. So this is going to be a negative. This one's going to be super big. So if I'm ordering them from least, the smallest number, to greatest, the smallest number here is going to be negative 6 to the 4th power without a parenthesis. The next smallest number is going to be negative 6. Oops, I'm wrong. No, negative 6, that's fine. Raised to the negative 4th, because that's going to be a number that's less than 1. Then we're going to have negative 6 raised to the 0 power, because that's 1. And then finally, we're going to have that big number, negative 6 raised to the 4th power. Okay, what is the difference between negative r to the third power, r to the negative third power, and r in parentheses, negative r in the parentheses raised to the third power. So negative r to the third power means negative r times r times r. The 3 is only attached to the r, not the negative sign. So this is going to be a negative answer when it comes out. R to the negative third means 1 over r to the positive third, or a number that's positive, greater than 0, but less than 1. And then negative r in parentheses raised to the third, that means this 3 is going to hit both the negative sign and the r, so this means negative r times negative r times negative r. So that's the difference between those 3 expressions. So if you think that parentheses don't count, that's not true. They absolutely do. So what I'd like to challenge you to do is go ahead and do 3 and 4. I know I'm over 20 minutes right now, but go ahead and do 3 and 4. Pause the video and then come back and check your work. So go ahead and pause the video right now using number 2 as your example and see if you can figure them out. Okay, 6t to the negative second, that means 6 stays in the numerator, the negative second only attaches to the t to the positive second. Now if it's all in parentheses, this is going to mean 6t to the negative second, that's going to be 1 over 6t, keep them in parentheses, to the positive second, because you want that 2 to hit everything inside. The parentheses make sure that it hits everything inside. Number 4, ooh, this is a good one. 5 over 3 to the negative third. That means the negative 3 is going to hit the 5, and it's going to hit the 3. So I could rewrite this as 5 to the negative third over 3 to the negative third, and since they both have negative exponents, they're going to flip spaces. So this would be 3 over 3, I'm sorry, 3 to the third over 5 to the third. This next one, 5 to the negative third over 3. The only thing that has a negative exponent is the numerator, so that one's going to go down. So it's going to be 1 over 5 to the third times 3. Now we can't multiply these guys together to simplify anymore because they don't have the same exponent, so they're not like terms. I know that I went over, but I hope that this was helpful. When you're working on the homework assignment, it says homework, but it's actually classwork, that says 0 exponents and negative exponents. The first section, 1 through 7, it's kind of a review that we just went through in this top section here, where it's going to be like a mixed practice kind of thing. So I would love for you to work on the first page of the classwork. I will see you next time, and hopefully this was helpful for you. And remember, anything raised to the 0 power is 1. Anything raised to a negative power, you're going to take the reciprocal. It's like a person taking an elevator to the next floor. If it's in the denominator, they're going to go up to the numerator. If it's in the numerator, they're going to go down to the denominator. Have a good night, and I'll see you tomorrow.